are going to see about the topic thermodynamics. Thermodynamics. The word thermodynamics itself has a meaning. So here the word thermodynamics has two different words. So which means thermo is a single word and dynamics is the another word. So the meaning of thermo means it is heat and the meaning of dynamics means object which is in motion. So now if we have to consider a system, let us consider a system. Now heat is applied to the system. Now we are applying heat to the system and now the heat starts to move from one end to the another. So simply we can say that thermodynamics is a study of heat or the study of flow of heat in an object. Okay. Now second thing, it is a branch. So branch of science. Thermodynamics is a branch of science that deals with two basic things. The first one is heat and second one is temperature. So as we know, if you are supplying heat to the system, the temperature of the system automatically increases. So the study of heat and temperature in science we are calling as thermodynamics. And at the same time, it is also deals with the conversion of heat energy into mechanical energy. It tells us if we supply heat energy, with the help of heat energy, how it can be converted into mechanical energy and vice versa. So by supplying the heat energy, we can make it to perform some work. Okay, and third one, it also deals with the macroscopic particles. So it is not micro, it is macro. Macroscopic particles like mass, volume, heat, pressure, temperature, and some of the easily accessible and directly measurable objects. So first, like once again I am coming from this. So this is the introduction of thermodynamics. So thermodynamics is a branch of science that deals with heat and temperature of a system, and also it tells about how the conversion of heat is used to make a mechanical energy or mechanical work, or how mechanical energy is converted, mechanical work is converted into heat. And also it tells about the macroscopic behavior of a particle like mass, volume, heat, pressure and temperature. At the same time, whatever things are easily accessible and can be directly measurable can be explained with the help of the thermodynamics. Okay, now next there will be a small question. How this thermodynamics has been evolved? So who gave this topic thermodynamics? Of course, there is no any particular person like who has given or who has invented or who has discovered this, but a person named Carnot in the year 1824 gave some basics ideas about the heat, converting the heat energy into mechanical energy, and hence it comes in the form of thermodynamics. So next thing is, before going into the thermodynamics, we should know about the four basic things. The first one is thermodynamic system. Second one is thermodynamic variables. Third one is surroundings, and fourth one is equation of state. So these four are called as a basics for thermodynamics. So why it is called basics of thermodynamics? It means without knowing what is that system or without knowing if heat applied to the system, what will happen to the system, or without knowing if I apply the heat, what are all the changes going to happen in that system, and also depend upon what is present, like atmosphere we call as a surrounding. So what is a surrounding? It's there. So these all to be considered, and finally we have the equation of state, that means conversion of a state into another. So first we will go one by one. So first one we are going to tell about the thermodynamic system. So like its system. As we know, system is a collection of particles, or simply we can say the collection of molecules. So as it's mentioned like its system, it's a large. So it is a collection of large number of particles which have some temperature, some heat, some pressure in that. That is we call as a thermodynamic system. So which means a large collection. It's a collection of large number of particles having heat, temperature, volume and pressure. So this is called as a thermodynamic system. So means we have to apply the heat and the heat has to flow. For that we need a system, and that system should already possess some heat in that. Along with that, after applying the heat, what are the changes or what are the variations going to happen in that? That is explained with the help of thermodynamic system. So without knowing a proper, or without having a proper knowledge about a thermodynamic system, it is very much difficult, or it is impossible to deal with thermodynamics. Second one is thermodynamic variable. So here thermodynamics is a general one, we know. Now here is a word called variable. Like for everything, like for example, we are taking a conductor. So this is a conductor. So as we know that conductor is a solid which has a regular arrangement of atoms. So it is considered to be the system now. So we are taking this conductor as a system. And in nature, this conductor is having its own temperature, own length, own volume, everything. So for example, even we can take an example of our human body. So when I am talking about the human body, even now my body temperature is different, but when I am going out, my body temperature will different. Means the body temperature varies from place to place. And even I have some normal body temperature, that body temperature is 36.7 and it is 98.7, like 36 to 98.7 Fahrenheit, 37 degree Celsius. So this temperature makes me to maintain, or this temperature or this heat makes me to do some mechanical work. In the same way, this conductor is naturally having some heat. On this system, now I am going to apply an external heat. I am going to apply an external heat, and hence that heat applied is also a variable one. So after applying the heat, and now the heat starts to flow inside the conductor. And one more important thing, we should always remember that heat always flows from the lower to the higher, or higher to the lower. It is always from the higher to the lower. And if you are supplying the heat always moves from the lower to the higher. If you are giving the external energy or external heat, it always flows from the lower to the higher, but automatically it always flows from the higher to the lower. So when I am applying the heat Q, it starts to flow in the conductor, and hence the temperature of the conductor now automatically increases. So I supply the heat to the conductor, and hence the temperature of the conductor increases. So depending upon the increase in temperature, that depends upon the increase in heat supply. Now there will be some increase in its length, or there may be some contraction in its length. So depending upon the heat supplied, or depending upon the material, there will be some expansion or there will be some contraction. So there will be a change in volume. So I am applying a variable heat. Because of the variable heat, the temperature will varies. Because of the variation in temperature, the size or length of the material increases or decreases. Hence there is a change in its volume. Hence we used to say that if the pressure, volume and temperature. So here we have to know about the pressure also. So what makes the pressure? So we know pressure is equal to force by area. Means force applied on a given area, and here the force applied is what? The heat. the heat applied on the given area will vary. So hence pressure is a variable, and applying the heat on that, its volume changes, so volume varies, and then its temperature varies. So these three are called as a thermodynamic variable. Now moving on to the third one, that is the surroundings. So surrounding is a common word. It is our atmosphere. Like I am keeping the temperature, like I am keeping the conductor in a particular place. In that particular place, for example, the room temperature is 37.6 degrees Celsius. I am keeping this conductor in a particular temperature. Not only the temperature matters here. It depends upon the humidity, it depends upon the pressure, and depends upon the area where we are doing. So all the atmospheric factors will affect the conductor. So whenever we are doing an experiment for a constant result, we should always consider the surrounding. Since if I am supplying a variable heat on that, some of the heat will be given out to the surroundings. So there will be a change. So that is why it is necessary to always consider the surrounding. And the last one is equation of state. So equation of state is a quite little bigger topic, but we are not going to deep into that. This equation of state, as we know that change of state means like changing from solid to liquid, liquid to gases, like conversion of one state to the another. For that, in thermodynamics, we have an equation, and that equation is called as PV is equal to nRT. This equation is also called as the ideal gas equation. So here, pressure, volume, and temperature. Here R is a constant. Here R stands for the constant that we call Rydberg's constant, and N stands for the number of moles. But we are not going to see now deeply into this. Just we are going to see about the basics, and we are going to move on to the laws. So next is the laws of thermodynamics. In thermodynamics, we have four laws. So we call first law of thermodynamics, second law of thermodynamics, zeroth law of thermodynamics, and the fourth law. But you can ask like why first law, second law, zeroth and fourth. Actually zeroth law was given at the third. But this zeroth law will act as a basic for first and second. So in order to give it the beginning, it's a first law. So we are naming it as zero. That is why it's called a zeroth law. So we'll go one by one. First we are going to see the first law of thermodynamics. The first law of thermodynamics was given in the year 1850. So it was given by Clausius. So in 1850, Clausius gave the first law of thermodynamics. In other words, the first law of thermodynamics is also called as the relation with the law of conservation of energy. As we know that energy can neither be created nor destroyed, but it can be transformed into one form to the another. Same way, heat can be never created nor destroyed, since heat is a form of energy, but it can be transformed from one object to the another. So that is why we call that it is a concept of the law of conservation of energy. Now, same concept like I am taking a system. According to the first law of thermodynamics, if I am supplying heat to the system, I am supplying a variable heat. So del stands for a variable heat. If I am supplying a variable heat to the system, and that system should be capable of doing some work. So means that system which I am choosing should do some work. So like that I have to choose the system. So in that system, now I am applying to the heat. Now as soon as I apply heat to the system, now the system absorbs the heat. Now the heat is transferred to the system. The absorbed heat by the system will be equal to the sum of the total internal energy and the external work done by the system to the surrounding. So it will be little confusing, like it will be little difficult to understand. So I am just applying heat to the system. Now the heat transferred here. So as soon as heat transferred to the system, this system has some internal energy, and that internal energy we are representing by del U. U stands for the energy, internal energy, plus some change in work done. Actually, change in work done refers to what? So when we are supplying heat, like I am giving from one direction, so this heat can flow away also to the surroundings. So which may move the particles which is present near to the system. So you can also move the particles which are near to the system. So the heat applied to the system will make the internal energy. Okay, next question will be there. What is its internal energy? As it's like kind of a total energy. Internal energy is equal to its potential plus kinetic. The total energy in the system. So when we are supplying heat to the system, the kinetic energy is a moving energy. So the energy which makes the particles in the system to move around, and it may make the particles to be heated up, and some of the heat energy is given out to the surrounding. So the heat supplied to the system, the changing heat or the variable heat supplied to the system is equal to the sum of the total internal energy plus the external work done. So here it's very important, it's not the internal work done, it's the external work done. The external work done by the system to the surroundings. So this is the equation for the first law of thermodynamics. And we are not going to see about briefly about thermodynamics, first law of thermodynamics. Just we'll see the applications and limitations. So it has some limitations. The first one is it does not tell about the direction of heat flow. So this first law of thermodynamics does not mention or does not tell about where the heat flows, in which particular direction heat is flowing. That is considered to be one of the drawback of or the limitation of first law of thermodynamics, and it is undefined. Undefined in the sense up to a certain, like you can say undefined means certain limit. So heat applied to the system, and hence the system is doing some work. Here it is like it's like a principle of the thermodynamics means heat supply, it does a mechanical work. But how much heat supplied and how much work is done, it's not mentioned clearly or it not tells clearly in the first law of thermodynamics. So for a certain limit, how much heat applied and how much work is done is not tell or it's not clear. So we are calling this as one of the drawback. And third one is the conditions. It does not tell us about under what conditions the heat energy is converted into mechanical energy or vice versa. So it does not tell us about whether the pressure should be constant, the volume should be there, the temperature. It does not tell anything about that. Just directly proving the heat supplied is equal to energy plus work done. So it is considered to be one of the drawback of or one of the limitation of the first law of thermodynamics. Now moving on to the second law. Of course, now the limitations of first law has been taken into consideration, and some scientists they started working on that why it is not being told clearly, and hence they have formulated the second law of thermodynamics, or simply we can say that the second law of thermodynamics is just the solution for the first law, the limitations of first law of thermodynamics. So here the second law of thermodynamics was given by two statements. The first statement is Kelvin Planck. So there are two scientists, Kelvin Planck statement, and second one is Clausius. Of course, the name is now quite familiar. The person who gave the first law, he himself started doing investigations why this much drawback is there, and he gave a statement. So we call Kelvin Planck statement and Clausius statement. And one more thing is also that the importance of the second law of thermodynamics. There was a famous personality, C.P. Snow. He saw that a person who don't have any knowledge about the second law of thermodynamics have been no knowledge about or no knowledge of any work of a Shakespeare. So it was told like that. So if a person don't know about any information about the second law of thermodynamics, have no knowledge about the Shakespeare's water. So that is, which means that it has been that much importance of our day-to-day life. That is second law of thermodynamics. Okay, now moving on to the first one, that is the Kelvin Planck. So just today we are going to see about only the statements and not about a brief explanation about this. So Kelvin and Planck together told, and you can also tell like this is about the heat engines. It is about the heat engines. So which means if you are supplying, if a system is having heat, so if I want to do some work on the system will take the heat absorbed and they will do an equivalent amount of work. That is a normal statement. How much heat you are supplying, that much work will be done. So this heat absorbed by the system will be equal to the equivalent amount of work done, and it does not tell us about like any how much loss is there. It does not tell us, but it tells about the heat absorbed will be equal to the equivalent amount of work done. Second one is the Clausius statement, and it deals about the refrigerator. It deals about the refrigerator. So it also told, like as we know that refrigerator means something always should be given external. So the external energy supplied, the external energy or external heat energy supplied should be how much it is given, there will be a low amount of work done by the system. So it has been again briefly explained by so many theories and so many principles, but we have to know about only the statement. So the external energy supplied to the system will be equal to a low amount of work, mechanical work. Again, these two statements have some limitations. First one, it is applicable only for cyclic process. It is like the second law of thermodynamics is only applicable for a cyclic process, and it does not tell us about a non-cyclic process. So this is the one of the drawback considered to be a limitation of the second law of thermodynamics. Now the third law, that is the zeroth law of thermodynamics. So for this we have to explain with the help of a diagram. So considering two systems A and B, considering two systems A and B having a thermal equilibrium separated. So A is having a separate thermal equilibrium, B is having a separate thermal equilibrium. Now when this is connected to a third system, that is C, now A, B and C will have an equal equilibrium. So that is the zeroth law of thermodynamics, which means heat always flows from one object to the another. The basic is that the heat always flows from, and next question you can ask like, why from when it is A and B, when they are separated, why can't the heat flow from one to the another? Yes, there are again two things we should consider. One is the adiabatic, we call adiabatic walls, and second one is the diathermic. The diathermic walls. So adiabatic walls are, it's kind of an insulator which does not allow the heat to flow. So when you are keeping an adiabatic wall between A and B, there will be no flow of heat possible between A and B. But when you are connecting a system C which has a diathermic, which means it is connected with both dia. With are connected, like heat from A also flow to B and heat from B also flow to C. So it all will get interchanged. All the three will now get an equal thermal equilibrium. So as we know, equilibrium means what? It is a constant, same. So it all will comes for an equilibrium. That is why it is called as a 0th law. Actually, this law is basic for the first and second, the flow of heat. But later on it was being invented and it was found out. So it was named as the 0th law of thermodynamics. So it's like thermodynamics is like not a small one. It is a very vast syllabus. There are so many applications and so many derivations, theories behind the first law, second law and third law. But we are not going to deep into that derivations and theories. Just today we have seen about only the introduction. Now, where are the applications? So where we are applying this first law, where we are applying the second law, and where it is this 0th law. 0th law is everywhere. Like if I have my two hands, both the hands have temperatures. So when I touch some object, now automatically I can feel cold or automatically I can feel hotness, which means the temperature from my hand is transmitted to that object. That is heat flow. It started heat flowing. This is one. Second one, like the food we are eating. So I am taking as a food. So food is a form of energy. That energy when it is going inside get digested and it's converted into a heat energy, and that heat energy is applied to do some mechanical work. That is why I am moving my hand, I am moving here and there. That is all because of the heat energy. And at the same time we can go for the automobiles, all kind of automobile engines. For example, starting from a bike to a train or an aeroplane, everything is working on the principle of thermodynamics. So that's all for today. So in one more class we can see about the theories, derivations for the thermodynamics. Thank you.